All right, my name is Gil Berman. I'm a front-end engineer at Airbnb.
My name is Brian Tom, I'm the SEO PM at Airbnb. Let's get started. So welcome to Airbnb, and this is what we had to go through in order to enable AMP onto our website. So let's start off with what is Airbnb. I think many of you guys know that it's just a home sharing platform. I'll just leave it at that. So this is our P1. This is our homepage. So for reference, we call our homepage and everything else special names. So homepage is P1. This is where you go and enter your your location. So if you want to look for a place in Amsterdam, you type in Amsterdam. This is our P2. This is our search result page. So this is, if you type in Amsterdam, these are the locations you get. If you type in San Francisco, and the next one is our P3 page. So this is the actual listing page. So just remember, P1 is the home page, P2 is the search result page, and P3 is the listing page. And with that, let's get started talking about AMP. So with AMP, we have to talk about what should we actually AMP. And to do that, there are a couple of challenges that we needed to figure out about which pages we should consider. The very first one is impactfulness. This is traffic, and not just getting random traffic into our site. This is about high intent traffic. Which traffic is actually going to end up booking on our website. The second one is page volatility. At Airbnb, we push out code every 30 to 45 minutes, so the page is continually changing. What this means for AMP is that a page might just randomly break AMP validation, and we don't want that happening.
Technical challenges. How difficult would it be to AMP the page? At the time, some of our pages that we were considering were still in a legacy framework, and that would make it more difficult to AMP the page. And page ownership. Do we own the page, or do other teams have a stake in that page? If we own the page, it makes it easier to AMP the page.
I think you go one more. So the big one, so page ownership, guidebooks. This page occupies our things to do in Amsterdam or things to do in San Francisco. Now, the SEO team actually built this product from the ground up, so for SEO-wise, it works. But the big problem is that the traffic's kind of low, and then the intent for the people coming in isn't very high. So for that reason, we decided, let's not AMP our guidebook pages.
P1, our home page. This page is the highest traffic page on the site, so it would be high impact if we AMPed it. However, this page goes through a lot of changes, and the ownership made it difficult to really choose this page, so we decided not to AMP P1.
And this is P3, our listing pages. So we actually started working on P3 for about 2 weeks before we decided to stop. The nice thing about P3 is that there was only one other team working on it, and the conversion rate is super low. Now, the conversion rate being low is really great for us, because if we AMP it, we might be able to get the conversion rate parity with P2. Unfortunately, it's built on a legacy framework, and the page was in constant flux because the other team was refactoring it. So for that reason, we decided not to go with P3.
And finally, P2, our search results page. This is also a very high traffic page. It would be high impact. A lot of people work on this page, but through a process of elimination, we decided this was the page that we would AMP. And here's a look at our traffic breakdown. Things to do, as you can see, is only 1% of traffic. It would have been very easy to AMP that page, but that's why we didn't choose to AMP it, because it's very low traffic.
But let's talk about the AMP minimal viable product, as much as I hate that thing. So first question asks, how does AMP work within our existing framework?
How does AMPing P2 interfere with our website infrastructure?
What does AMPing P2 do to the workflow of other developers in the company?
How does this impact design experience and the overall product?
So with these basic questions that we want to answer, there are also quite a few other questions that we decided let's procrastinate and let's not think about it for now. The first one being how do we integrate this into a fully functioning product with the rest of the company? Well, the problem is we're creating minimal viable product, so there's no reason to worry about how a fully functioning product is going to work with the rest of the company.
We didn't want to address all of the complexity concerns like validation, although along the way we did actually end up have to address some of those, and we'll talk about that later.
We didn't want to worry about getting buy-in from other teams. We wanted to create the MVP and let teams actually see how it worked in order to get them to buy into it.
And how do we integrate AMP into our experimentation framework?
The last one is who's actually going to be owning AMP? I mean, the SEO team is creating it, but in the future, is the SEO team going to be maintaining it? Are we going to create a special AMP team, or is maybe website infrastructure going to handle it?
Obstacles. So one of the first major obstacles was that our page was timing out, server-side rendering, it was timing out 16% of the time. Compare that to less than 4% for a canonical page. And when it times out, this is what it looks like whoops, on the right side here. It's just a blank page versus what it's supposed to look like on the left. Now, normally this wouldn't be a huge problem because Google is supposed to link to the canonical version of the page if the page doesn't validate. However, there was a bug, and this is actually what users saw.
So how do we actually solve this problem? Well, we implemented CDN caching. That means whenever Google calls our AMP page, the first time that it actually renders, so it may have failed the first 3 or 4 times. The first time it actually renders, we go ahead and cache that in the CDN level. And then from then on, for the next 30 minutes, Google will continually serve the CDN version. So this effectively dropped our timeout rate from 16% to virtually 0.
New features broke AMP. If an engineer added a single image tag to the page, that would break AMP validation. On the other hand, an engineer might add a feature that didn't break validation, but it still created a really bad experience. Here's an example where the entire search results just rendered blank. Architecture solutions. We wanted to make our pages AMP compatible without having to recreate a separate version of the page, and we also wanted to be able to use our existing framework, which is based on React. So why is this so hard? Well, for security and performance reasons, AMP has a lot of limitations, or a lot of constraints. So here, specific to us, AMP doesn't support important. Our CSS and JS library that we use, called Aphrodite, adds important to every style. AMP doesn't support inline styles, and with React you use a lot of inline styles. AMP only supports style tags, which appears in the head, and Aphrodite inserts the styles in the body, and AMP limits CSS size to 50 kilobytes, and as we added more features, we ended up going beyond this limit. So inserting heads into the style, styles into the head. So Hypernova is the name of our server-side rendering service. It's a Node.js service. And the way it works is that the user makes a page request, Rails renders an ERB template, and the ERB template makes a call to Hypernova via this call to render React component. And this is what it looked like before. And then this is what it looked like after. So now we're using Hypernova to render the entire page. And this way we can insert styles into the head. We published this as an open source project called Hypernova AMP. Important. This is what it looks like in React when you insert styles into a div using the CSS function. Now I should mention, if you don't know what CSS and JS is, or React, this is JavaScript code, or it gets transpiled into JavaScript code. It's not actually markup. And this CSS function ends up generating the eventual styles. And this is what it looks like at the end after it's been generated into actual markup. So what we did is we added a Node.js environment variable and conditionally rendered important or didn't render important depending on whether or not we were rendering an AMP page. What this also means is that now we have 2 bundles. One bundle is for AMP, and one bundle is for the canonical page. Inline styles. This is kind of a simplified version of how this works. But the idea is that what you pass into CSS, that's what arg is here. And there's a factory function for creating class-based styles. So we recursively call this function in order to convert any inline styles into class-based styles. The 50 kilobyte CSS limit. So one of the things here is that we actually weren't generating any extraneous styles. Aphrodite actually generates styles on the fly so that every single style that's being generated is actually being used in the page. But still, is there a way to eliminate some styles or get the style, the total number of characters in the styles to be less? So this is a look at what the intermediate object looks like when you call the CSS function. And the cool thing about this is that since it's just a JSON object, it's easy to transform. And the resulting styles look like this on the right. Now notice here that we have max width 743 pixels. These styles will always be shown in an AMP page. So it turns out we can just eliminate this line of code. So the rule here is if max width is less than or equal to the mobile size, you can just remove the media query and preserve the styles. Here's another example. Now we're using min width. Notice that none of these styles will actually be used on a mobile device. So in this case, we can actually just eliminate all of these styles. And we got a bigger reduction in CSS as a result of this logic. So the rule here is if max width is greater than mobile size, you can eliminate the rule. Finally, we did one more thing, class name minification. Originally, our class names looked like this. And then after minification, we got them to look like this. It's like hello style was what was in code. And then after that is a hash that's appended automatically by Aphrodite. And we added this as a feature to, oops. Sorry about that. Anyway, AMP validation. So utilizing AMP HTML validator, which is available on NPM, made available by Google, we're able to start off with a mock data object, which we capture by doing a regular page load. Now, the cool thing about React is that your entire page is represented. It's just a single function, in this case, magic carpet bundle. And it just takes an argument, which is the data that you need to display in the page. So we can just treat the entire page as a unit in a unit test. So this is a really easy way to integrate validation into our continuous integration system. The only downside of this is that it's a very heavy operation. Most unit tests don't do something this extensive. And it has caused unit tests to time out because of the threshold that we set on unit tests. And this is a look at our React Components sandbox. This is Storybook. It's an open source project. We didn't create it, but we use it, and we customize it for our needs. And when you develop a React component, it makes sense usually to develop that component in isolation, as opposed to in the context of the entire page. And that's what this component sandbox is used for. And what we did is we added a tab called AMP that simply renders the component, just the component, using the AMP renderer. And this is a really easy way for engineers, while they're working on a component, to also check to see if that component works with AMP. And it's actually not in this screenshot, but you can also just open the dev tools and see if there's any validation errors. And here's an overview of the open source projects that we use. The ones in white are the ones that we didn't create. Hypernova AMP is what we use for server-side rendering. And React with Styles interface AMP Aphrodite is what does the style elimination. And we added a PR to Aphrodite, as I mentioned earlier, which is what does the class name minification.
So with Gil going over a bunch of the technical issues, I'm going to go over some of the product issues that we did run into with AMP. The very first one that we did run into, do you mind if I grab the clicker?
Sure.
That'd be easier. The very first thing that we ran into was user flow issues. So user flow works really well with AMP as long as you're logged out or a first-time visitor. The problem starts appearing when you have logged-in visitors as are now dropped into a very, very confusing experience. People that are returning visitors are used to seeing P2. They're used to seeing a more customized version of the landing page or of the search result page. And they're used to be able to check the trips and their messages, and we're not able to offer that with AMP. And so yeah, so just to reiterate, the initial page load is just a logged out experience, and we needed to figure out how to get a logged in version of P2 for people to actually use. Another issue is with deep linking. As we all know, if we have AMP enabled, it requires a second click for you to actually get deep linked into the app. So At Airbnb, we care a lot about the user flow and the user journey, and being unable to dictate when users are able to go to the app versus when they actually go to the AMP page is an issue for us. So there's very, very polarizing ideas about whether or not this is an optimal user experience or a suboptimal user experience. Another issue is just iteration. AMP makes it very difficult for us to experiment, and we live and die by our experimentation framework. And we have an in-house experimentation framework that we use, and AMP doesn't make it very easy for us to start integrating with it. So as we know, experimentation in another domain is extremely difficult, so iteration with AMP was a pain for us. And the last one is stability. While we were testing AMP and running experiments and trying out new things, a lot of things kept on changing where developers would randomly break either AMP by, like Gil said, like adding an image tag, or in other instances, they would actually introduce new features into AMP on accident that were AMP valid. So while unit tests can go ahead and capture all the errors that you have, if somebody introduces a working component into AMP, then it doesn't really matter. Like, it's going to get introduced, and it screws up all our test data. So on that end, like, stability was also another issue. So what did we actually learn from all of this? That one, communicating with outside teams outside the SEO team is very challenging. That while Gil has overcome many of the technical hurdles, the experience as a whole feels fractured. P2 isn't going to be the greatest experience. So what do we do with this? Well, how do we go and address all these problems in one fell swoop? This slide doesn't actually matter. This one does. To answer the question, let's dial back to when we first started on AMP. When we first started working on AMP, we also started working on a new product. We call it Magic Carpet. And Magic Carpet is our landing page system that we designed. And Magic Carpet is a page that is created specifically tailored for first-time visitors coming in from search engines. And here is what Magic Carpet looks like. On the left is our regular P2 page. You can see the search results in a small little search bar. And on the right, you can see Magic Carpet, which has the same content, it has the same results, but the biggest difference is that it has all of these, like it has a very, very strong call to action that tells users exactly what to do. Now, what does this actually do? Well, one, it redefines the user flow. It redefines the booking flow because people coming in this page now know exactly what to do. Rather than going to a P2 page and being a little bit confused, now they're entering a P1-like experience. They're coming in, they know that they need to search. We limit the exposure to a certain demographic, and we focus the product design for that demographic, and then we end up having a much more polished experience. Now, how does this relate to AMP? Well, after we launched Magic Carpet, we actually increased conversion rate for SEO bookings by 6%. This is before we introduced AMP to the page. Now, this page seems perfect for AMP since it is by default a logged out experience because it is a landing page system. So right now, we've enabled AMP on the page, and we're undergoing testing in order to see bookings conversions. On the plus side, we have seen like a drastic increase in time spent on page, drastic increase on pages per session, and a drastic decrease in bounce rate. Now, I'd be remiss to talk about AMP if we didn't talk a little bit about logging and experimentation. Now, there's 3 types of experiments that we would want to do. In the interest of time, I'm only going to go over traffic, but the first one being traffic, the second one being bookings, and the third one being downstream metrics. You want to be looking at the amount of P3 views, how many people are searching with dates. So let's talk about the deep link problem. Let's say we run an experiment for AMP. So we have, so in treatment, we'll have AMP, and in control, we'll have regular pages. So if you go ahead and AMP up a page, the user journey goes like, you go to Google, you hit AMP, and you perform that second click, and then you get deep linked into the app. The second step, or for control, you click on the result, and then you get taken straight to the app. Seems like a pretty simple experiment, right? So what's the problem here is that it actually leads to an artificial inflation in metrics. Now, why does it do this? Well, the big problem is that we are unable to track the amount of users coming in from deep linking. Now, why is this an issue? Is because iOS and Android don't have a strong enough, they don't give us the referrer information. They don't tell people that we're coming from Google. Now, how this works with like paid search is that you have a URL parameter that is added when people come in. But people coming from Google, you're unable to actually, you can't add a URL parameter to a Google search result. I mean, you could, but that wouldn't be great for SEO. So as a result, we can't actually like experiment with traffic. We can't see it like if there was an incremental increase in traffic because of this issue. Because you'll always have more people that are going to be hitting the AMP page because we can log that impression. We're unable to log impressions coming from deep linking. So while the difference may be 1 or 2%, like in 1 or 2% in an experiment, that's a big deal. So what are the solutions for this? Well, the very first one is to actually port them over to the Airbnb page first. So they'll go and they hit the Airbnb page, and then we capture the information, and we instantly deep link them over. So there's a really quick context switch, and that's great. It works. But at Airbnb, again, like user flow, the design, the behavior matters a lot. So we actually need to undergo testing to make sure this doesn't impact bookings. And a suboptimal solution, in the interest of time, is that we just wait. Because as we know, Google, like browser will end up supporting AMP to show the actual canonical URL. So just to recap, I don't know, this is all the product issues and all the technical issues we came up with AMP. And these are the solutions that we came up with. But I'm Brian.
I'm Gil. Thank you very much.